Greenhouses allow crop yields to be increased by up to 300% compared to open field, thanks to optimal climate control and higher planting density. With hydroponic systems, this yield can be multiplied by up to 10 times, optimizing resources and maximizing efficiency. This functional automated greenhouse mockup integrates the following essential components. DHT11 sensor which measures ambient temperature and humidity. Soil moisture sensor which activates the irrigation system when necessary. Light sensor which detects the light intensity of the environment. Arduino Uno board which processes the data and controls the actuators. Mini water pump powered by a 9-volt battery and controlled by a relay for automated irrigation. LEDs, which act as visual alarms when variables set values. Connection cables and 330 ohm resistors, which ensures the correct operation of the circuit. This set of elements allows to effectively simulate and control the conditions of an automated floriculture.
In this part of the project, we focus on the soil moisture sensor and the automatic operation of the water pump. The sensor is inserted into the soil and measures how wet or dry it is. This value is sent to Arduino and converts it into an easy-to-read percentage. When the moisture drops below the threshold we set as ideal for the plant, the system automatically activates the water pump. As you can see, when the soil is dry, the pump turns on and starts watering the plant. Once the sensor detects that the soil is moist enough, the pump turns off. And this process prevents overwatering and ensures that the plant only receives water when it really needs it, optimizing water usage. This feature is especially useful for people who aren't always home or want to automate plant care.
In this part of the project, we focus on the DHT11 sensor and the photoresistor to monitor the environmental conditions inside the mini greenhouse. The DHT11 sensor measures the temperature and humidity of the air inside the greenhouse. This data is sent to the Arduino, which processes and it takes action according. When the temperature goes outside the range we defined as ideal for the plant, either too high or too low, the system automatically turns off the warning light. This lets us know that the conditions are not suitable and we need take action to protect the plant. On the other hand, the photoresistor detects the amount of light in the environment. When light levels drop to low, it has a warning signal to indicate that the plant is not receiving enough natural light. This alert allows the user the response in time on adjust the condition has needed for the plant. Thanks to this sensor and the automatic control through Arduino, the system can detect and alert us about environmental change, helping maintain a more favorable settings for healthy of the place growth.
The graphical interface developed for these systems allows the user to monitor in real-time case physical variables within the greenhouses, such as ambient temperature, soil humidity, and light intensity. This constant display makes it easy to monitor the conditions necessary for optimal flower growth. The system is configured with three reference plants widely grown in Colombian greenhouses: Brazilian face boldo, orchids, and lilies, each with their own ideal growing ranges. Based on the user's installation, the interface automatically adjusts the recommended thresholds, values for temperature, humidity, and light, and the user can modify these limit values or thresholds according to specific conditions or particular preferences. These thresholds act as reference points that the system uses to trigger alerts. Finally, it should be noted that without the Arduino software, you cannot take the code stored on the board, so Python depends directly of the Arduino. However, Arduino also depends on Python through serial communication, where the thresholds are updated.